for me. I didn't even finish eating my dinner. How did you like the show? What did you think of this episode this week? Look, I didn't even have time to change out of the video outfit. I literally film these things like sometimes we're talking a few hours before they get uploaded and then we watch them. So anyway, let's see if I can keep up with the comments this way. I don't have Shroom Day tonight. We're gonna miss him. He's down for the count tonight. Or maybe we'll see him next weekend or next Monday. So my face is gonna be close to the screen so I can try to read some comments here. Man, maybe we should screw the phone mount and I should just hold it so I can actually read. And pardon me, I'm chilling at a Sheetz right now. Stopped at Sheetz to get me some refreshments and didn't even finish my dinner. Got some spicy ramen sitting next to me waiting to get devoured here, but I got to chat with you guys. Thank you, Mr. Chubby Hubby. We got Mr. Chubby Hubby as our moderator tonight as we're chilling here in the live chat. I got to remember, this live chat was not directly connected to what we just watched on my channel. So we're here discussing in an after-party chat Turing patterns. I don't think I need to be wearing the headphones, do I? Why don't I just turn my truck off here for a minute? There we go. So we just got done watching the premiere. So folks that might be jumping into this live periodically, I'll try to remind folks what we're here for, because some people might not actually understand what's going on. But good evening. Happy Monday. Thanks for watching the premiere with me. If you're some of the originals with me on that one, I know Mr. Chubby Hubby was there. Did we get Dean to jump over? Is he in the live with us tonight? If he is, great. Welcome. I already mentioned Shroom Day making it tonight, unfortunately, but we'll miss him. All right, let me see if I can get caught up here. Supper first with me. I tried, but I was so busy trying to get the video ready today that finally had a chance to sit down and eat something. I was watching the premiere. But these things happen. Hey, we got Dean. Loving Dean, the God Machine. I don't even know what that name means, but it sounds provocative. All right, anyway, what does it say here? I need to clean the smudges off my glasses. Give me 1 second, guys. I cannot even read the chats. Looks like I'm trying to read through smog or something. Hold on. Hope everybody's doing well. All right. There we go. Now we can read some chats. Oh, and if you're here with me right now, it looks like there's 4 of us. Well, 5 if you include me. But if you're here now, go ahead and hit the like button. If you've got a like button, hit it. That'll help boost the outreach of this live and maybe more people can join us. There's been a few of these Monday Night Lives that have gotten me brand new subscribers to the channel just because it got shared with the algorithm. So hitting the like button is doing this channel a huge favor. So thank you. All that being said, what were we talking about now? I cleaned my glasses off. Oh yeah, I was going to read somebody's comment here. Here we go. I'm here just doing some dishes. Oh man, help me out. Remind me, Dean, if I know you outside of YouTube or not. Hey, the live is how I found your channel. Oh, there, you just reminded me. You read my mind. So that's pretty cool. You're testament to the fact that the algorithm works. People hit the like button. It helps share it with more people so more people scroll through. I'm horrible at this whole YouTube thing when it comes to like promoting and using the algorithm to its potential. I believe that if I used more hashtags in the descriptions of my videos, that it would probably be put in front of the right audience and therefore generate better viewership. But I don't know. I have no clue. I need like a YouTube team. People who are good at all those other things, and just let me do my thing on YouTube. All right, anyway, let's see if I can keep reading some comments here. I shared you out, Mr. Jeff. I know you did. Shoot. You share my stuff more than I share my own stuff, I think. But I did remember to share this video tonight. I shared the premiere. And I did a post for it too. So does that count? We both in PA. Oh, yeah. I think you might have mentioned that on something. Your hashtags can help people find the lives more. There you go. Thank you. Whereabouts in PA without giving your full GPS coordinates? I'm in Western PA, somewhere beating around the bush, the Laurel Highlands, we'll say. I'm south of Johnstown, north of Seven Springs. We are west of Somerset, but we are east of Greensburg. How's that for a vague location? You're south of Pittsburgh, so you know where Greensburg is, probably, maybe. I'm going to be east of you, I imagine, though. All right. So, I kind of gave the answer away in the live chat when I posed the question, but the question will be there in perpetuity for future viewership. The question I'm speaking of is my little trivia when I put up the 9 different blocks of Turing patterns. I drew those on the side of my truck, and then the weather came and washed that off. So I'm glad I took a photo of it so I could then upload that as part of the video. But I had to do a voiceover, and I asked the question, do you recognize any of those patterns coming from nature? And I gave the easy zebra answer. But the upper left corner, which is probably my favorite of all the Turing patterns, is the one that's labyrinthine, or kind of has, it's not straight up and down stripes, and it's not dots. It's that halfway in between where some of the dots connect and some of them loop and whatever. But that formation is found throughout nature. But the one spot I saw it and was like mesmerized, just blown away by the beauty of it, was on the puffer fish. So you guys that's my answer for that upper left corner when I said it came from the ocean. But I bet there's other oceanic critters that have that pattern too. Isn't there something called brain coral? I think. Because someone commented coral, and that made me think of brain coral that may actually follow that same pattern too. So there you go. Let's see, what do we got here? Okay, Cool Hand. Where's he at? Did I miss a chat? Commander Cool Hand's here. Chestnut Ridge and Laurel Ridge. Yeah, that's where I'm at. You got it. Oh, shoot. What do we got here? We have to link up sometime to forage mushrooms. That would be awesome. Well, maybe October this month, just because season's running out. Mushroom hunting's all year round, but the real good hunting season's going to be, summer, fall, primarily fall. But I found some of my cool mushroom finds in the wintertime, including my favorite mushroom, birch polypore, wintertime mushroom. One of the most delicious mushrooms I've ever had was a wintertime mushroom. The velvet shank mushroom, Flammulina velutipes. And then you've got your turkey tail, which can be found any time of year, middle of summer, middle of winter. So, all right, let's keep reading the chats here. It looked like fingerprint as well. Yeah, you're right, Mr. Chubby Hubby, you are spot on. It's actually been proposed that our fingerprints follow that same mathematical equation, that Turing equation, that forms our fingerprints too. I was reading some PubMed or some kind of science journal that was talking about fingerprints and Turing patterns. So, yeah, the amount of time that goes into making a Monday night video, the video is 15 minutes long. I probably spent 15 hours in reading preparing for the video. And then the actual filming is, because I'm usually just doing it live, you're getting 15 minutes of filming. And then you're getting about a couple hours of editing. But you're getting 15 hours, most likely, of actual book time of me studying and learning about these things, so I can actually know, present it and know what I'm talking about. But yeah, your fingerprints, Turing patterns. So yeah, that was a good eye there to notice that. Anyway, where are we at here? Dean called Coral at the premiere. Yeah. So I think there is a brain coral that follows that same labyrinthine pattern or whatever. See if I can remember how to say Daedala. What did I say? Daedaloid or whatever. Freaking, excuse me. Daedaloid? Did I say it right? Daedaloid? Daedaloid. I don't know. Shoot. I'm waiting. I'm actually kind of low-key waiting for the day when somebody makes a, what do you call that when you take all these cuts and edits from people's multiple videos to get all the clips of them doing the same thing over again? Like a supercut? Is that what they call that? Of me constantly screwing up my words and botching them or something. Probably get a few minutes of that off of the videos I have already. So, hey, we got a couple new faces showing up into here. Hi, good evening. Happy Monday night. I'm Mr. Jeff, and we're talking Turing patterns found in nature, primarily found in fungal hymenophores. We're talking the caps and the gills and the pores of mushrooms, and some of the more intricate designs of these. Some of them aren't pores, some of them don't have gills, some of them have teeth, some of them have these labyrinth patterns we're discussing. So I just looked up and saw a couple new numbers up here. So here's how I know if I got new people. If my head count is greater than my thumbs up. So if you guys like this live, that'll let me know that you are here and accounted for. So if new faces show up and aren't accounted for, I can repeat myself. Help me help you. So let me keep reading in the chats here, and I want to get to any questions if y'all had them from the video. Hey, when you're working with words like these in the fungi world, I don't blame you for messing some of these words up. I know, right? And I consider myself well-versed in vocabulary, both English and foreign languages. Like, I've taken many languages, including in seminary, taking Greek. So a lot of these, like science, Latin binomial, we say Latin binomial, but a lot of these binomials, the genus species names, are not just Latin, but some of it comes from Greek, much of it. And not only are we talking I can't even say the words, the taxonomy, the naming and the IDs of these mushrooms, but also a lot of the vocabulary words in mycology. Like when I'm talking about a hymenophore and hymenium, hymenophore comes from Greek. So a lot of these things I'm familiar with, or if I don't know it directly, it doesn't take me much to figure these things out. Words that end with "phore," that phore in biology, in biological terms, we think of something that's a something for. What's the "phore" for? Well, "phore" means to bear. It comes from the Greek word "pherein," which means to bear, to bring forth. So anything that is a something for is something that bears forth or brings forth the thing that's mentioned in the name. So a hymenophore is something that bears the hymenium, or bears forth the hymenium, if that makes sense. That's your hymenophore. That's what these language things do. They help me read some of these deep journal work, the PubChem and PubMed papers. I understand them because they're always using big words, and I feel like it's almost a crime. Like, Why can't you just speak in plain English for some of us folks trying to get this knowledge? You guys are keeping, you're bogarting the good knowledge from us in these research literatures that if you don't have a, college level vocab, you're just depending on other people to tell you the truth about some of this science. Now, I understand why they use the good vocab. It's because it creates a consistency and conciseness of the reading. So, I mean, you got people who are coming at this from different countries with different native language. So using English as your language to communicate globally is bad enough. Let's use good, clean, proper English to make it somewhat smooth. But my argument still stands. Somebody's got to break it down in plain English for us folks so we can benefit from all this research. When I discover some health benefit of this or that in a fungal situation, it's not like it's on the front page of the newspapers. Nobody's talking about it. I'm like the only person on the planet talking about some of these weird things. So, hey, let me give it to you. Anyway. Man, thank you so much, Mr. Chubby Hubby, for doing a great job moderating, because I'm not keeping up with this stuff. Chromatophore or a chromophore. Yeah, that would be something that brings forth or bears color. A chromophore or chromatophore. So there you go. Did I talk about those in a video before too? And I think I talked about that in the video where I talked about the color changing mushrooms. Go check that video out if you haven't seen that one. By the way, if I got new people jumping in here, hit the like button, help the algorithm share my live. I don't know how long I'll be live. Sometimes I go over an hour. Sometimes I don't. Depends on signal, depends on the topic. Anyway, let me keep reading here. Just so you know, I'm out in the middle of nowhere, PA at a Sheetz. Pennsylvania's best gas station. Fight me about it. All right. To ensure the propagation of the species. Oh, I need to back up one. Okay, I'm reading backwards here. I wonder what led to mushrooms using so many different ways of spreading spores instead of just one or two ways. There's many very fascinating. So, let me keep reading here. Mushrooms really are the kings of propagating their species, that's for sure. So here, I kind of touched on it briefly. I didn't really go into it because it wasn't the topic du jour. But when I drew the cross-section of the gills or the pores, and that's the thing, if you cross-section the gills or the pores, you have the same thing. You have an up section and a down section. You have the side walls of the pore tube, and then you have the hole itself, the bottom out. Gills are doing the same things. The labyrinths, they have the walls of the labyrinth, and then the empty gaps. So you have fungal material and empty space. And so the alternation, the periodization is there. Once you cross-section it, can you distinguish a gill from a pore? In theory, if you know what I'm saying. But I'm kind of rambling on. So you've got the up part. We'll just refer to it as a gill, cross section of a gill going vertical. Actually, I should do it this way better, right? Up, down. Gill pointing down. On that side wall, the side wall is your hymenium, and along the hymenium is going to be these what do we say? Ballistospores. I don't know if I'm using the right word here. Imagine a spore launcher like a catapult or a spring-loaded mechanism. And it flicks. Kind of like the old school folding the paper footballs and we flick them back in middle school. It's like they're flicking the spores out off the surface of the hymenium. But we're talking microscopic. Like you're not seeing this happen with your naked eye. And the distances we're talking about this flick happening and kicking off those spores are measured in the micrometers. Really tiny amounts but it has to be precise. So with evolution, with let's say 1 billion spores and genetic coding, I'll say, I'm making this up, okay? So bear with me. I'm kind of making up a thing based off of natural premises. You know, we understand how these genes work in propagating themselves, but what I'm creating is kind of just imaginary scenario to explain. All right, I said all that to say this. Maybe in the DNA of a particular species of mushroom, it has multiple copies along its genes of the formation of its gills. And why does it have duplicates? Because if a genetic mutation came along, say some UV damage or a toxin in nature, some environmental thing caused the DNA to be damaged in a spot where it's encoded on how to make its gills at the right thickness, at the right gap measurements, right? All that's calibrated in its genes. And in that gene sequence, if it got disrupted, it's plucked, right? I'm just kidding. If it has multiple copies of that gene throughout or in different locations, one of them going mutated won't mess up the whole thing. It'll still have that information. So I'm hypothesizing that a lot of these structures, like the gill or pore or whatever the hymenophore structure, its greater structure is probably multiple coatings of it. That's why you don't see great differentiation of morphology within the same species. If that makes sense. I don't know if I'm making sense here. Okay, so within the same species of a Trametes versicolor, they all got the really tiny micropores, right? But its cousin, Flacosa, has the labyrinth. So species to species difference in morphology, but within the same species, Trametes versicolor, all of its brothers and sisters have the same spore or pore size and shape. How come it doesn't get a single mutation that causes it to go labyrinthine? Is because most likely multiple genes are expressing or have the ability to be expressed. So if one gene coding that says your pore size is like this, if it mutates, it has backups that say the same thing. Do it this way. You can't screw this up because we're going to repeat the message along the DNA. Did that make sense? Whereas something that only has a single gene expression, all it would take is a simple methylation or some kind of other damage to that portion to cause it to be expressed differently, therefore causing the mutation to manifest itself within one generation. So it can happen in the same species. I don't know if I'm making sense for y'all, because I feel like I'm talking a little bit deeper than even my video is going with it. But that's my theory or my hypothesis on why you've got the different morphology species to species so easily, is because it doesn't take much in the gene coding to change it. But if you have multiple spots where it's expressed on the single strip of DNA, you can't screw up a single species morphology once it has it locked in. It's going to take a lot more than just, some gamma ray incredible Hulk radiation. It would take a lot for it to get off course. I say off course because it's currently on a course of morphology of what it looks like. Did I make any sense tonight? Sorry, I'm not reading, so therefore I don't even know what you guys are saying. Let me back up here. Ooh, let me catch my breath for a second. All right. I wonder what led to mushrooms using so many different... Okay, we've got that part. I'm past there. Sporing is never boring. Yes, sir. All right, thank you, Loving Dean, the God Machine. All right, not to go too far off subject, but that's what but what's the longest a spore can lay dormant and still grow? I'm following along. Cool. Okay, so the longest a spore can stay dormant, still grow, it's going to depend on more than just the time, I think. So a spore can have the potential, depending on the species, depending on how its spore, like the outside shell, is formed. It can be super durable and withstand different stressors environmentally, like heat, like pH levels, light, UV radiation, all that kind of stuff. We're gonna have to go Google that one because I don't know the answer, but I already know it's years. There's spores on my dash right now. Here, let me just grab Big Boy right here. This thing's probably dropping spores on my dash every day. Just dropping them down its holes. Can we see those? The pores on this are micropores, by the way. Barely visible to the naked eye. Definitely not visible to my low resolution camera. I've got other species up here, like this reishi, Ganoderma tsuge. Cross section, you can actually see the tubes that drop the spores. Yeah, I got poor lighting. Better lighting, create better resolution. There we go. Anyway, this has been dropping spores for over a year. Those spores are probably still viable, even though it's been getting UV radiated on my dash. If the conditions are right, spores are super durable. But I don't know what the actual answer is, if we're talking decades, centuries. Can you imagine some archaeological dig in Antarctica? They go beneath the ice and they yank out some spores, and now you got some Last of Us scenario going on. It's like some horror movie. Anyway, they already did an Antarctica horror movie, didn't they? Somebody tell me in the comments what that movie was. All right, anyway. I have shiitake logs, lions logs. Turtle Ridge Homestead, welcome. Good evening. I've got Mr. Chubby Hubby as my moderator in the comments. Thank you, Mr. Chubby Hubby, for greeting the folks joining us. I have a hard time keeping up with the comments, but we're just kind of musing and chatting about Turing patterns found in the hymenophores. That's the hymenium bearing part of the mushroom. What's a hymenium? Hymenium is the surface of your gills or the pore linings, the part that releases the spores. That's the hymenium. And the hymenium, that lining, covers, if you think of a gill, the sidewalls of the gill or the sidewalls of the pore, that's all lined with your hymenium. But the gills or the pores, that whole portion of the mushroom is called your hymenophore, the hymenium bearing part. Now I'm just geeking out with you guys. But that's what we're talking about. We're talking about hymenophore morphology, or how they're shaped different, how some mushrooms produce gills, some produce pores of different sorts. What's your favorite design? If you didn't see the video that I premiered tonight at 9, if you didn't catch that, I actually have some pictures of different Turing patterns. And Turing patterns were a concept that was created by a man named Alan Turing, who died in the 50s. He's been gone. But before he passed, he was influential in saving millions of lives in World War II as a computer scientist and codebreaker. But his knowledge of mathematics and his love of biology led him to observe these patterns in nature and come up with a mathematical equation that could explain how some simple pathway could lead to such different, diverse art, right? Like whether it's the stripes, gills, whether it's spots, pores, whether it's these twisting turns of a labyrinth design, even hexagonal patterns can be explained by this Turing equation. But I said all that to try to catch the rest of y'all up to speed if we got new faces in here. Go and watch the video, though. I encourage you to go check out tonight's video I premiered at 9 earlier tonight. We're just doing our after party chat, hanging out with Mr. Chubby Hubby, who's been following my channel for a while. Great supporter. And we got a few new faces in here, a few reoccurring faces. Good to see Loving Dean, the God Machine, back for subsequent weeks joining us. Thank you. I don't remember Turtle Ridge, but thank you for joining us tonight. Where are we in the chat here? Let's see if I can keep up. Is it fair to say then that the most resilient species would be fungi then? Because the more I learn about fungi, the more I see how advanced they are. It's possible, right? I don't know. I almost feel like the more simplistic the organism, the more of a chance it would stand at being like having a resiliency, like bacteria forming an endospore to survive even above boiling water temps. If you think of bacillus bacteria. But if you're talking about macroorganisms like plants, fungi, animals, fungi are super resilient. Even more than resilient, though, I look at how they're like unstoppable because their abilities to create enzymes based on their environment. You place some of these fungi in different environments, including novel environments with novel chemical compounds. And at first, they may not know what to do with these things, but it's almost like they figure out what kind of chemicals to produce. When I say chemicals, what type of proteins? A protein is not just a regular ass chemical, right? A protein is a very complicated string of sometimes hundreds of amino acids linked together in ways where they can bend, twist, and fold and coil in ways to create machines. That's what an enzyme is. It's a machine made of amino acids that are all twisted and folded in ways that are now chemical machines that are able to, in some cases, rip bonds apart from atoms from other molecules. How are they able to manufacture that? We don't even understand DNA's code. We're still learning this stuff, and they're not able. Not only are they able to just understand it, but they take it to the point where they are like, I don't know if they're just writing new DNA code in themselves to create these enzymes, because you don't create an enzyme in nature without a DNA code to give you the blueprint on how to formulate, because that's what DNA is. It's basically the blueprint. It's the script that tells what types of proteins to build, whether they be enzyme or non-enzyme. I'm fascinated by that. But anyway, where are we? Antarctica spores turn people into zombies. All right, where are we at here? I hope it's the slow ones. Those fast ones scare me. Yeah, can you imagine the sequel to The Last of Us? The Fast of Us. You better run. All right, where are we at here? I hope. Oh, oops. Link to tonight's video. Thank you, Mr. Chubby Hubby. Always keeping the chat up to snuff, because I never keep up with what you guys are saying in there. We got Tiger's Blood 43. Hey, welcome. I know that guy. All right, good to see you. Sorry, I'm trying to read my chats here, so my eyes are down at the bottom of the screen. Howdy and welcome. Nice hat. Yes, thank you. You like that, don't you? So what do we got right now? Man, we got 8 of us in the chat right now. We've been just talking about Turing patterns in nature, primarily in fungi, and how these gills, pores, or other patterns like labyrinths and other patterns that are found in the spore-bearing portions of these mushrooms, how the differences between such elaborate designs is really not that different when it comes to the math behind it. So we were talking about that in the video, but that was in the video at 9. The open chat is up for discussion of anything, guys. It's a free for all. Mr. Chubby Hubby's just he's my blocker. He's to make sure no bullshit gets in the chat. Other than that, though, we get to talk about whatever we want, and I'll probably be hanging out here maybe a little bit longer. It bounces between 5 or so people in here. I might stick around another 10-15 minutes. My dinner's getting cold. My hot and spicy ramen's about to be cold and spicy. All right. What do we got here? Don't get me started on the rabbit hole of fungi being ancient, advanced, multidimensional beings. Oh, shoot. Tell you what. And I've talked about this, and I have a few videos on my channel where I already do that. But I want to incorporate more of taking folks in the woods type videos where it's one-on-one, just open discussion, similar to like a podcast, but instead of sitting down at microphones, we're in the woods walking and talking, like an interview style. So if I get you in the woods, Dean, we go foraging, we might be having an open discussion about some of that stuff. I can get into some crazy deep topics too. Man, they wouldn't have known what to do with a guy like me on a show like Coast to Coast, if you remember that show. Shoot. I got some theories. I have to keep most of that stuff to myself just to keep you guys thinking I'm human. If I told you all the stuff I thought, you guys wouldn't believe I'm actually a human being. All right. Did fungi create life, or was the beginning of life? Or is it the end of life? Is it perfectly evolved and we are its slaves? Those are all great questions. So I've proposed this idea. You ready for this? We have a microbiome, right? These bacteria, yeast, and other organisms that live in us and on us. But who's to say they are just not? What if they are us? What if they are a collective hive mind that has formulated an ego, we'll call it, and that's what we think we are? We think we are this one individual when we're actually, the body is just a mech being operated by trillions of tiny organisms operating together. And here we are, thinking we are the thing. No, we're not. We're just a mech, a giant cybernetic organism. Anyway, did I say that out loud? Man, they're going to ban me from YouTube. All right, trying to keep up with the comments here. Where are we now? Weren't mushrooms here first on Earth? Yeah, that's what they believe. Shoot. Didn't they theorize that there was, I mean, they got fossilized evidence of fungi that were as big as trees are today, right? Large fungi. But I believe the theory is that they were the big dogs before plants took over. Let's keep going here. Besides bacteria and such. Right. I really think fungi is Earth's nervous system. That's a theory too. And the fact that the mycelial network of all these species interacting with each other. Fungi, bacteria, protists, mushrooms, animals. There's nematodes and worms and other critters, insects in the soil that interact with these things too. And by interact, I think it could be said they communicate, right? Like, isn't it weird? You could sit on a park bench at a park and like, watch a bird get in a quarrel with a squirrel. They'd be chewing each other out or something. Like, are they actually speaking the same language? They act like they are. It's like all these other life forms know how to communicate with each other, and we're the ones that are stuck, like, we don't know what the heck they're saying. I think they have like a universal language or something. The man will call it spreading sporaganda. Wait. Okay, I'm trying to keep up with you guys in the chat here. I'm mid-Missouri, morel season. Turtle Ridge, Homestead. You're from Missouri? I've been to Missouri once, I think. Maybe twice, but I know I was in Branson. I passed through on our way coming from Illinois going to Tulsa and down into Texas. Anyway, where are we at here? Mr. Chubby. You have the best one-liners. All right. What if they are us, the basic consciousness, a fungi parasite? Are you talking like I was talking about? Are you saying like, what if the fungi are they are us? I don't know. Chatting always makes it hard to understand what people are talking about. So don't mind me if I don't get what you're saying. But different theories of consciousness exist out there. I mean, there's theories, these are ones that I didn't make up, that even though they may not be us, they have a heavy influence on our personality, on our mood, on who we are. And I'm talking our gut flora, because the gut flora produces neurotransmitters like serotonin. And that could also be tied into things like having a sweet tooth or different cravings we might get. And that compulsion to buy the donut from the gas station might not be you speaking, but it might be the yeast, the candida albicans, right? I don't know. What did I do? I earned a new subscriber. How did I do that? Wait, let me back up. I think the comments are moving fast on me here. All right. Let's see here. Where were we in the comments? Okay, you have earned a new subscriber. Is it because I went through Missouri? Well, the natural processes on Earth heavily rely on fungi, right? Like if you take away, like if you take away all fungi, the natural world would not be. I think that could be said about all the different organisms, right? I mean, if you eliminated one species, the whole world won't fall apart. Species come and species go. Some naturally occurring and some human influenced, right? We've killed off many species too. But that didn't destroy the earth. But you know how they say things like if the bees died, we'd all be gone in 3 years? I mean, maybe humans would be. Maybe our different constructs and civilization would collapse. But Earth would keep going. Earth is not species dependent. Species are Earth dependent. That's a theory for you. Good luck, Elon Musk, moving to Mars. My abrupt ending of the feed, and special thanks to Mr. Chubby Hubby for moderating tonight. And I'll see you guys next Monday for a new episode. Peace. How do you turn it off? It's funny, I can't never turn this off when I need to. It only turns off when I don't want it to. All right. Wait, did somebody just come back? As I'm about to end this, it looks like somebody came back. I don't know who's here. Hey, there we go. We're ending.